6, 7, 8, and then we have 9. 5, 6, 7, 8, 9. There we go. So then you might be wondering, well, what happens to 10? Well, 10 looks like this. 0 and then 1. That's what we're doing. We are learning how to read the abacus. After we learn how to read the abacus, we will go into adding, subtracting, multiplication, and division. Hey, Mitch, welcome. GLaDOS, welcome, welcome, welcome. Let me know if you guys have any questions. Any questions at all? Okay, how are we doing? Are we all right? Okay, cool. So again, we're going to do is we're going to go 10. And then after 10, this is 11. After 11, right, this is 11. And then what are we going to do? We're going to do 12. Because this is 12. We notice the ones, the 1 and the 2, right, and the 10s and the 10s and the 1s. What we're going to do is understand how we read the abacus. So we did the 1 through. We do 1s here. 1, 2, 3, 4. All this is a value of 1. These all lower beads has a value of 1. So we have 1, 2, 3, 4. All of this is 4. So this is the horizontal bar, and this is the horizontal bar that tracks the beads. Because this is a horizontal bar that tracks the beads, now we have 4. When we do this, this is 5. When we look, we have 6, right? We have 6, 7, 8. That's what 8 looks like. And then we have 9. All these beads, when they are together like this is all 9. This is 9. That's all 9. That's 9, 9, 9, 9, 9. So what we're going to do is understand that when we do this is 9. And then if I do this is 90. 90 is because of our 1s and our 10s. And then we have 1, 2, no. 10, 20, 30, 40, and then 50, 60, 70, 80, 90. After 90, we have 100. How are we doing? Anybody have any questions? What's going on? Okay, so the first thing I'm going to do is understand how to read the abacus. When we understand how to read the abacus, then we can go into adding, subtracting, multiplication, and division. So if I can ask you guys, welcome everybody to my room. Now, if I do this, right, what number? Oh, you know what? Here's even better. What number do you think this is? So if this is my number, what number do you think it is? Thank you so much for liking the live. Raspberry brains. We're trying to make wrinkles in our brains. So if we look, we have 1, 2. Thank you, Mitch. Yes, easy, right? Easy. So we do 1, 2, 3, 4. This is 4 because it's the value, because the beads are touching this horizontal bar. This is 4, right? If I did this would be 40. If I did this would be 400. I did this would be 4,000. And then that would be 40,000. So then you might be asking, well, what happens to 5? Well, the top bead will always be 5 no matter what. Here's another question. Why am I over here? The reason why I'm over here is because I have this dot indicator, and this dot indicator tells me where my 1s place is. When I look, this is my 1s, my 10s, my 100s, my 1000s, my 10,000. Now, what happens is if I decide to choose this this dot, like I choose a Pokemon, I could have this as my 1s. If I have that as my 1s, I move everything over and I go 1s and 10s. But notice I don't have any more 100s. So what does that mean? That means that I cannot have 100s. So what I need to do is I need to move everything over and utilize this one to be to have 100, 1,000 and 10,000. Does that make sense? Anybody have any questions? Let me know. So what we're doing is I'm just talking to myself because I'm not sure if anybody's in the room, and we're going to be counting on the abacus. We have 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. That's how we do 10. Oh, good. I'm so happy you're here. Great. Thank you so much for commenting. What we're going to do is this is 10. When we look at 10, this is 1 and this is 0. Me too. Hey, Mitch. Okay, good. I saw you commented, but I wasn't sure if you were here. So then we have 11. When we have 11, this is what 11 looks like. And then after 11 is 12. And that is what 12 looks like. Do we have any questions? Let me know if you have any questions. If not, I eat I eat dry cereal. Bruh. I pour milk before my cereal. All right. So what I'm going to do is I'm going to count to 10 again. Nope. I'm going to count to 10 again. So when I do that, I have my ones. If I have my 0, this is all 0. Because this is 0, then I have 1, and then I have 2, and then I have 3, and then I have 4. So all these beads touching this horizontal bar is counted as counted. So this is 4. When we look, we have 5. Nope, that's not 5. This is 5. Here we go. There's 5. So what we're doing is reading the abacus. And so what we do is we have 5, and then we do 6, and then we have 7, and then we have 8, and then we have 9, and then we have 10. 10 looks very familiar, looks very similar to 1. 1 or 1. No, not 1 or 1. What this looks like is going to be the 1s and the 10s. So on my 1s and my 10s, thank you so much for sharing the live, Mitch. So I was here last night at 2 a.m. Oh my goodness, Becky, that's right. You guys were like crazy. Please do the matrices. I only know the Matrix, the movie. I don't know what matrices you're talking about. So what we're going to do is we're going to have 11. When we have 11, we have 12, we have 13, and then 14. I love the movie The Matrix, and I love all of the 4 matrices. Yes, that was a very good movie. I love that series. So what we're going to do is we're going to, hey, hello, Mathematic Fanatics. You have 1,000 gates. Oh, thank you so much. Thank you so much, One Ink. So what we're going to do again is we're going to do 1, 2, 3, 4, and then 5. Because we have the value of 5, then we do 6, 7, 8, 9. Now we have 1,000 likes. Oh, 1,000. So we have 1,200, 200 likes. That's what that looks like because it's 1, 2, 0, 0. When we look at our place value, we have our 1s, our 10s, our thousands, our 1s, our 1s, our 10s, our thousands, our hundreds, our thousands, our 10,000s. I am so sorry. I am messing that up. Thank you so much for the like. Thank you so much for the follow. All right. So again, what we're going to do is when I do this, what number do we think that is? If I did that number, this is the number I want. That's the number I want. What number do we think that is? Please put in the chat what number you think this is. Oh, you guys are so, well, I'm trying to get here earlier. So it's not so late. Yes. Is it 27? It is 74. Thank you, George. You are way better than my 4th period teacher. Oh, thank you. I appreciate that. So it is 70 because we have 5, 6, 7, and then we have 1, 2, 3, 4. So this number is 74. When I write it, it will look like this. 74. Thank you, George, for your comment. And toast on jelly, yes, you're right. At least it's 1. All right. That just means that you're not trying. That's what that means. So we have 1. That's what 1 looks like. Toast on jelly. I don't know if you're still here, but thank you, George. Right. So then we have 2. After 2, there's 3, 4, and then 5. After 5, we have 6. What does 6 look like? 6 looks like this. 6, 7, 8, 9. Because we have 9, we have 10. 10 looks like this. 1 and 0. With my question, we had 74. So we had 70, 5, 6, 7, and then we have 4. 1, 2, 3, 4. That was the question that I asked. What number that was? Thank you. Thank you again. So what are we going to do is we are learning to read the abacus. After we learn how to read the abacus, we will go into adding and subtracting on the abacus. Now you might be wondering what this thing is. This thing is a 7-column abacus, and what we're doing is we're learning to read the abacus. Does it matter what color it is? It doesn't matter what color it is. It just matters on how to move the beads. Now, when we look at the beads, if you notice, there's these edges. Because there's these edges, you want to be delicate? No, you want to be gentle. Be gentle with the beads, right? You just need to move them up and down like this. They're very easy to move. So what we're going to do is simple to use, easy to understand. And what we're trying to do is we're trying to understand how to move the beads. All I'm doing if I want to add the 1 is that's all I'm moving. I'm just touching the edge of the bead and I'm just moving it. I'm being very gentle. right? When we do math, we want to be gentle. We want to be happy when we want to be happy when we do math. And so when I do this, right, I have 4, I have 5. When I add the 5, notice I'm only using the edge of the bead, right, to move my 5. So we don't want to be aggressive with our fingers. We want to be gentle, and we want to be, just because you have big burly hands, you should be able to move it. This is a standard size abacus. Jesse asks, what's the point? I mean, besides basic addition, are there any benefits? There are benefits, just like playing the piano and doing Sudoku, playing video games, playing puzzles. They're all the same, right? What we're trying to do is we're trying to understand what? Brain gymnastics. So if you ever played with Sudoku, it's one of those things. If you ever did crossword puzzles, it's one of those things. If you did word searches is another thing. If you have kids, they're great for kids. I mean, is it great for adults? It's great for adults, so you don't get Alzheimer's. I mean, if it's really push comes to shove, what we want to do is we want to have brain gymnastics, and we want to keep our mind sharp. So, what is the point? That's the point. The point is, if you don't like it, then you can step off. That's all I have to say. I'm getting kind of tired of that question, though. You know what I mean? Because why? It's apparently that you don't have any kids. Because I think it's the greatest thing next to sliced bread. Sorry, I'm feeling a little salty because I'm getting a lot of comments to be like, this doesn't make any sense. I'm like, okay, that's fine. That's fine. But that's what the point is, right? The point is if you do Sudoku and if you like puzzles, then this is what would be good. How's that? That sounds a little bit better. But yeah, I get a little salty when people ask me, well, what's the point of this? Well, if that's the point, then why do we teach kids how to add? Right? Why do we teach kids how to add? Why do we teach kids how to do math? Because they're supposed to learn. What's the point of doing? Sorry, I'm sorry. I apologize. No, I do feel a little salty because there's some people that just be like, there's no point to this. I'm sorry. I do apologize. I'm feeling a little salty because reading some of the comments in my pump. So let me take a breather. You're right. So if you're interested in puzzles, right, like jigsaw puzzles and so forth, this would be one of those things that we would be doing. So if we look at it, we do addition, subtraction, multiplication, and division, if that makes sense. Yes, in case our George, it's okay. It happens to me too. Yeah, it's kind of one of those things like, So, I mean, anyways, I mean, I've been doing lives too. I can see how addition and subtraction yes, there is a way to do. Thank you, Trey, for the question. Is there a way to do multiplication? Yes, there is a way to do multiplication and division on the abacus. Yeah, right, Jesse? Whew. Sometimes it just, yeah. So I'm trying to get off I enjoy the lives and I enjoy the questions. So I do appreciate your question. Thank you. I do appreciate it. Yes. So the point would be, if you like puzzles, these are great. These are great to have. And to have the brain gymnastics. And that was the one thing that I was trying to figure out is like, how do I introduce it to senior citizens so then they can, thwart off Alzheimer's. So when we look, Victor, please teach. Right, Victor. Thank you. So what we're doing is we're learning how to read the abacus. After we learn how to do that, and thank you, George. Yes, when the cell phones run out, we will have this for batteries. But then if you get tired and you get sleepy, then you can't do it because you will not have the energy to do anything. So Victor, if you're still around, this is how you count 1. This is 1, this is 2, 3, 4. Because this is 4, anytime the beads are touching the horizontal bar, this is being counted as 4. Now we have 5. If you notice, the top bead will always have 5. If you want to be poetic, we can call these the heaven beads, and these are the earth beads. When we look at it, we know what 6 is. Do we know what 6 is? Well, we know what 6 is. 5 plus 1 is 6. And then we have 5 plus 2 is 7. 5 plus 3, 5, 6, 7, 8 is not 8. 5, 6, 7, 8. 1 plus 3 is 8. And then we look, we have 9. 5 plus 4 is 9. 1, 2, 5, 6, 7, 8, 9. So if you notice, we can do some counting on, and that is a kindergarten skill. When we look, we can also do 10. Because why? This follows and this mimics the way we write our numbers. When we write our numbers, we have 10. This is a decimal system, right? Our decimal system is a 10 base. It's not 5 base. It's not binary. It's a 10 base. It's a 10 base. It's a decimal system. So when we look, this is 10. We have 10. So notice the top beads is a value of 5. If I want to do 15, that's what 15 would look like. right? So if I did 11, right, 11 is 1 and a 1. If I did 12, it would be 1 and 2. Ready for a test. George, what do you think? Are we ready for another test? So then we have, if we want to look, we have our place values. So when we look at our place values, we have our ones, our tens, our hundreds, our thousands, our 10,000. When we look, we have our ones and our tenths, and it sits between the ones and the tenths is our decimal place. So after our decimal place, we have our tenths and we have our hundreds. Becky, do a test. Okay. Okay. Okay, okay, okay. So let's do a test. Oh, I didn't add this to the shop. I got to add this to the shop. So what we're going to do here is we're going to, I'm going to test you. Yeah. Okay. I think what it is I just got to be a little bit on earlier. All right. So the first thing we're going to do is understand how to use this maze. This maze is about starting here. When we start here, what I want to do is I want to know what the number is, and then that number will tell us what path to go. So this number here, tell me what number this is. I'm sorry, I can't do that. All right, so we do this and we do that. What number do we think that is? Hey, Chase, like food? I hope you can do multiplication. Yes, we can do multiplication, but it depends on how far or how quickly the class will go. It always depends, and then you can actually do division as well. But it all depends on the class. Thank you. Yes, thank you, Trey. Thank you, Becky. 61. Thank you, Victor. Wow. Victor knows. Victor knows. We're 61. So we do 61 and we're over here. Then we do this. I should learn to clean my stuff. So we have, no, that's not what I want. It is this one, this one, this one. Nope, I want to make it nice and clean. There we go, there we go. There we go. So what number do we think that is? If we did that, and then we did this, what number do we think this is? This is a 2-digit number. Thank you for the 39. Thank you, Becky. It is 39. How are we doing? Thank you, Mitch. Okay. How are we doing? Yeah, you were okay? All right. So the next thing we're going to do is 39. And then what's after that is this one over here. And we have that. What number do we think that is? All right. So we are done with that. Are we done? We're going to continue on. We can do a 3 digit. We can do 3 digits. Because I got 3 digits. And I haven't done my 4 digit yet. Okay. We do that. So is it 11? It is not 11. It is 51. The reason why, Chase, the reason why is because the top bead will always be a value of 5. And then the bottom bead is a value of 1. So when we count, we have 1, 2, 3, 4, and then this will be 5. So notice that this is the top bead, this is 5. And because this is 5, and then this is 1, we have 5 and 1. And now we have 51. Does that make sense? So when we have 51, we're going to go over here, and now we're over here. So when we do that, we have a 2-digit. What is our 2-digit? If we did this, and we did that, what number do we think it is? 64. Yes, Becky, thank you. 63 looks like this. 60, 5, 6, 1, 2, 3. That's what it would be. Yeah? How are we doing? 64. So I go over here, and now I'm over here. So, it's all about attention to detail. And if we have that number's easy. That number's easy. We should get that number. Yes. Thank you. Thank you, Becky. All right. I think Victor left. All right. What's after that? There's this one. This one's easy, too. Let me move it up. Let me move it up. That number's easy, too. We have this and that. 99. Yes, thank you, Becky. 99. And then we're over here. Wow, Becky's really fast. Thank you, Mitch. Yes, thank you. I don't know if Chase is here. So then we have what? This one and then that one. 91. Right. Good. That makes sense? So what are we going to do? We're going to do 91. So after 91, thank you, Mitch, we do this one. What's after that? We have this one, and then we have that. Never been more confused. No. No. That's a really interesting username. 75. Yes, 75. So we have this one. The top bead will be the 5. Thank you, Becky. So no. Ha, 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 ha. TNG. Welcome back. TNG. Balls, you're here. All right. No. No. I don't know if no is still here. So no. 1, 2, 3, 4. All the beads touching that is 4. And then what's going to happen is this is 5. Because 5, I am. Oh, I need to show you guys this. Still here? Good. Okay, good, good, good. Okay, Chase is still here. No is still here. No! Okay, sorry. Okay, 5, right? Does that make sense? This is the value of 5. Because this is the value of 5, the top bead will always be a value of 5, no matter what. So as Becky and Mitch has mentioned, this is 5, right? This is 50. 50 looks like that. That's what 50 looks like. And then 4. 1, 2, 3, 4. So now we have 54. Does that make sense? No? So the question is 54. My next number is here. When we have 5, now we can do 6, 7, 8, 9. Now we have 9. On the ones place. Well, what's after 9 is 10. 10 looks like that. What number do we think this is? If I have 1, 2, and then 1 over here, 25. Yes, thank you, Mitch. It is 25. Because how do I know? Because if this is my ones, I have my tens. I'm 10, 20, 30, 40, 50, 60, 70, 80, 90. So what we're doing is we're talking about our decimal place. So 25. And now we're over here. Oh, can't see it. Thank you, Chase. Thank you, Mitch. Thank you, Balls. Thank you, Jay. This is as confusing AF. No. No one can explain it. Dang, that makes so much sense. See? Yes, thank you. It is 58. Thank you, Becky. Thank you, Ball. Thank you, Mitch. Yes, right now? But Jay says it's confusing. It's not confusing. How do I know? Because come on. 1, 2, 3, 4. I don't know if Jay is still here. Jay, are you still here? Last one. This is going to be the answer to the universe. Okay. I've only been here for 2 minutes. So you can't be AF if you've only been here for 2 minutes. It would have been different if you were here for a half an hour and then you would have been like AF. Okay, 1, 2, 3, 4. Does that make sense? Don't worry, I'm confused. Him Jones, 42, right, Mitch? It's the answer to the universe. 4, this is 4. 1, 2, 3, 4. And then we have 5. This is the value of 5. Him Jones. And J. Hamilton, how are we doing? Does that 5? Does that make sense? This is the value of 5. This will always be the value of 5, no matter what. These are all 5s. Blah, 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 blah. That couldn't be 63. No, it's not 63. It is not 63. All the beads on the right under the bar is equal to 1. All the beads above the bar is equal to 5. Yes, thank you. Thank you, thank you, thank you. So what we're going to do is this is 5. Now, when I do this, this is 5. And then we have 6, 7, 8, 9. After 9, we have 10. Why is 5 there, but 50 is 1 to the left? So yes, this is 10. So when we look at it, and thank you for that comment, because I need to find my little place value. So thank you, Autumn. Yes, the answer to the universe is 42. So Jay, when we look, we have our place values. We have our ones, our tens, our hundreds, our thousands, our 10,000. When I was counting, I did 1, 2, 3, 4, and then 5. Notice that 5. Then we have 6, 7, 8, 9. And then after 9, we have 10. When you mentioned it was 50, you should put a post-it backwards on the back to show the number spaces while you move it around. Place value. Thank you. Note, it makes sense. Now it makes sense. Come on, you can't tell me AF. This is what I needed. I get it a little, yes. So then when we talk about 11, this is 11. How do we know? It's 1 and 1. This is 12. We do 1 and 2. When Jay was asking about 50, 50 was a 5 and a 0. Does that make sense? 5 and a 0. So we can do 61, 62, 63, 64. Make sense? So then we have 65. After 65, we have 75. Him Jones. Does that make sense? This is what I needed to see. Thank you, Jennifer. Thank you for the dancing eyes. Okay, good, good. So what we're doing is, in the beginning, when we were coming in here, we were talking about how to read the abacus. And this is a maze that I created. If anybody is interested, I am selling this if you wanted to know more about the abacus. But we will continue on to doing 3 digits. Here is my 3-digit equation. No, not equation. This is a 3-digit abacus. What number do we think this is? Thank you for the follow, him, and no. Such a strange name, no. Okay, yes, thank you. So we have 5, and it's 3 digits. 5, 7, 5. 5, 5, 6, 7, 5. Yes, thank you, Aaron, and no. Yes, and Mitch. Whoa. No balls, not one. If there is a dot on the black. Oh, yes, you're right, Chase. Yes, you're absolutely right. That's a very good eye. Good eye. So if you notice there's these black dots. These black dots is where I put my ones indicator. I could choose this one if I was like a Pokemon, and I could choose this one as my ones indicator. But if you notice, if I chose this one to my ones indicator, I can only do this one, the ones and the tens, and I'd have no more room for hundreds. So this one would be mute. Right? That's why we would start in the middle, not middle, but this is why we started with third column. So because this is 575, we're down here. When we look, right? When we look, we can use this one over here. So now my answer is this, that, and this. What answer do we think that is? Thank you for the follow, Sandra. Chase says 0. What? Oh, yes. 9, 1, 4. Thank you, Becky. Thank you, Mitch. Yes. So that makes sense. Why does it make sense? Because if we count 5, 6, 7, 8, 9 in the hundreds column, right? In the hundreds column, just like that. Oh, can't see that. In the hundreds column, right? And then we have the 1 in the tens column and the 4 in the ones column. 1, 2, 3, 4. That's what that looks like. Great. So now we have, where are we? Oh, we're going up here. We're going up there. There we go. Okay. Now, what number do we think that is? Is this a tricky one? This is not a tricky one. Hello, Leon. Welcome back. Is it 60? It is 60 because it's a 5 and a 6. Yes, it is 60. You're right. You're absolutely right because there's a 0 here and there's a 0 here. Yes, thank you, Chase. And so when I do 60, this is my next number. My next number is this. So when I readjust it, it'll be this, it'll be that, it'll be this. What number do we think that is? Excuse me. 893. Yes, thank you, Aaron, Becky, and Mitch. 800, 5, 6, 7, 8. 800, 9, 5, 6, 7, 8, 9. And then 3. 1, 2, 3. Yep, exactly. So then we did the 3, 803. We're over here now. And then this one is a 3-digit maze book. Am I a physicist now? Maybe. You can be whatever you want. 571. Yes, great. 571, and we're coming down here. So we have this next number. I wish you were my teacher when I was in school. Ah, Chase. I thank you for that. I appreciate that. When I'm not salty with my comments. Oh my gosh. Sometimes those comments really get to you, you know? Okay, sorry. Let me focus. So we have this number, 6, right? 8, 5, 6, 7, 8, and then 5. Thank you, Becky and Mitch and Aaron. Yes, 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 yes. Fantastic. Easy, right? Simple to use, easy to understand. Easy to understand, Jay. Easy to understand. Him. Is it easy? So when we do this, we have that. Oh, did we do that? Oh, no, we already did that one. Oh, no, we didn't do that. We did that. Read a bit. Yep. Wait. Hello. Hello, Melinda. Hello. Hello. Thank you, Mitch. Yes. 8, 9, 5. 8, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, and then 5. Yes. Okay, so we have this one, and then we're going down to here. What number do we think that is? Thank you so much, Melinda. Yes. So what we're going to do, let's do a little review for those people that are just coming in. We're going to do 1, 2, 3, 4. All the beads touching this horizontal bar is considered counted. And then when I do this, this is 0, and then this is 5. The top bead will always be 5. My answer, thank you, balls, is 931. 931. Yes, thank you. Heading out. Oh, thank you, Mitch. Have a good one. Have a good night. 931. Thank you so much. Thank you so much. So then this is the top bead is a value of 5. Because it's a value of 5, then we do what's after 5. What's after 5 is 6. 5, 6, 7, 8, 9. After 9 is 10. And what number do we think that is? So if I have this one, this is my 400s. Thank you, Aaron. Thank you, Becky. Yes, 20. Yes, and then 6. 5, 6. So thank you, thank you. Hey, welcome back, CompuBear. Welcome back. So we have 426. 426, yes, thank you. And then 426, we're over here. And what number do we think that is? We have that number, this number, and then that number. Yeah, right, Becky? Easy, easy. Thank you, Aaron. Thank you, No. See, No? Easy. Balls, thank you. And CompuBear. Yep. And Jay. Thank you, Jay. We have this one, right? Yes. Easy, right? Yeah, you can't tell me AF. Come on now. Thank you, Chase. Yes, thank you. This has been super interesting. Really? I appreciate it. Do you ever sleep? I did get some sleep. This one number, and then this number, and then this number. Thank you. I appreciate that. Yes, 500, because this is the 500, right? When we look at it, we have 587. 508, 5, 6, 7, 8, 7, 5, 6, 7 in the ones. Thank you. I'm gooning. I don't know what that means. Okay, we're done. We're done. We're the last one, and then we can start going into adding and subtracting. I'm old, and I don't know what these new terminologies are. Oh, God. Okay, good. Should I be blocking rando? Okay, so we have 283. Yes, thank you. Thank you, Jay. Thank you, Aaron. Thank you, Melinda, Becky, and Aaron, and CompuBear, and No. Don't block, but it's weird. Okay, thank you, balls. Thank you I appreciate that. Okay, so what are we going to do? What we're going to do is understand when we move the beads, right? We're moving the beads. We have to understand that we want to be happy when we do math. We want to be delicate, gentle. We want to be gentle with our math. So when we look, you notice that it's easy to move the beads. They're very easy to move. Because it's easy to move, right? Even if you bump it, your answer will be wrong. So you've got to hold it and stabilize it with your left hand. When you hold and you stabilize it with your left hand, and say you flick too hard. If you flick too hard, there. If we flick too hard, then your answers will become wrong. So don't flick hard. Don't be like Zeus in Thor. Live. So don't be like Zeus and flick too hard. So what we want to do is we want to make sure that we are gentle with our beads, right? So that is about adding, and that's about how we read the beads. Okay, what are we doing now? What we're going to do now is we're going to understand how to move the abacus. When we move the abacus, what are we doing? We want to know is we're moving the abacus. So that means we're going to go over here and we're going to start moving the abacus. There is a book that I have, and what we just did is we did the beginning parts of bead recognition. We have some activities to make sure we understand how to read the numbers, and then we have more activities. Now what we're going to do is we're going to go towards the back of the book, and we're going to start understanding how to add. When we add, you notice that we are going to focus on the add-in. We're not going to focus on the result. The focus on the add-in. This is an add-in. The add-in is the thing that we're adding to. That's an add-in. So with this add-in, we want to know about the journey. We want to focus on the process and not the result, if that makes sense. Why? Because in school, we're always teaching the kids, oh, how do you make an 8? It's like, no, that's the result. What I want to know is how do you use or how do you add a 1? So if I have 7 and I add the 1, I'm going to add the 1. I'm only going to move the 1 bead. This is the 1 bead I'm going to add. So my final answer is 8. Again, what we're looking at is we're only looking at the add-in. When I do 1 plus 1, we don't need to memorize our doubles. We just need to show that if I add the 1 and I add another 1, I get 2. Does that make sense? How? How do I move the beads? I move the beads by just using my thumb and I push it towards the abacus. Towards the horizontal bar. So when I'm adding 2, I want to go to the horizontal bar. When I subtract, I'm going to go away from the horizontal bar. So here's my question. If I have 6, how do I know this is 6? This is 6. 5, 6. When I have 6 on my abacus, I want to add 1. I'm going to go to the horizontal bar. Does that make sense? Let me know. So then after 1 is 2. After 2, right? We're going to look at it. We have 6. I have 6 on the abacus. And now what I want to do is I want to add 2. When I add 2, hey, Angel, welcome back. Thank you, CompuBear. So when I add the 2, I'm only going to move the 2 beads. I'm going to move the 2 beads together, right? I'm going to do, because we're big people, we can move things together. So when we do, we don't want to do 1, 2. We want to do 2. And we're going to move the 2 beads. Good evening. Good evening, Angel. All right. So again, what we're doing is we're not going to memorize our doubles. We're not going to be like, oh, 2 plus 2 is 4. We're not going to memorize that. What we're going to do is we're going to look at our abacus and we add the 2. And then my question is can I add the 2? Can we do it? So yes, we can add the 2 and there we go, right? So my final answer is 4. So notice what I'm trying to do is I'm to show where the beads are, right? What? You like that, balls? I got more. You lost me before you lost me before you even started. Hello. Hey, RTX, welcome back. Your father's keeper. If I have lost you before I've started, then I'm not sure if I can help. That doesn't make sense. So here we are. We're going to add the 5. When we add the 5, this is my question. We're going to add the 5, right? And then we're going to add the 3. When we add the 3, thank you, Tammy, and thank you, RTX, for sharing the live. What we're going to do is we're going to add the 3. When we add the 3, can we do it? Can we do it? Thank you. So we have 3. 1, 2, 3. Again, we're going to be big people. Oh, yes. Thank you, Becky. It will be 8. So our final answer is 8. Because why? Because I added the 3. So your father's keeper. I'm not sure if father's keeper is still here. Thank you for the heart me. So we're going to count. You're right, CompuBear. We're going to count again. We have 1, 2, 3, 4. After 4, we have 5. Anytime the beads are touching the horizontal bar. Oh, you're still here. Oh, good. So anytime the beads are touching the horizontal bar, it's being counted. So if you look, these beads that are not touching the horizontal bar, it is not there. Better tell father to find Sean or something. I think most new people that are confused are lost because they don't know the places of the abacus. Oh, that's a good idea. So I can do this. I can put a label here and say the 1s. So when we look, this is the 5, and then we have 6. 5, 6, 7. 5, 6, 7, and then we add 1. It's 8. And then we have 9. 5, 6, 7, 8, 9. And then notice when I do this, this is now 10. When we have 10, we can do 11, 12, 13, 14. I'm sorry, I should do that again. 10, 11, 12, right? 1 and 2, and then 13, and then 14. And after 14, we have 15. Yeah? Good. Yes, thank you, Chase. I appreciate that. So when we do that, right, we have 16. And what we were trying to do here is we were trying to add. When I show you how to add the 5, I'm adding the 5 here, and I'm going to add 3. The question is do I have enough beads to add the 3? I do. So I'm going to move the beads up to add the 3. Notice that I flicked too hard. I was being like Zeus in Thor, and I flicked too hard. So then my questions or my answers become wrong. So make sure when you do the abacus, be gentle. Be gentle and be happy. Be happy and you know it. Do some abacus. All right. So the next thing we're going to do is understand that we're going to do plus 4. Adding the 4, there's not a lot of questions to add the 4. Why? Because there's all these 4s. That's it. So either we add the 5 and then plus the 4, or we have a 0 and we plus the 4. That's the only thing. So adding the 4 is easy. So then obviously adding the 4, after we add the 4, we want to subtract. When we subtract, notice it's going to be taking away from the horizontal bar. I have my question. I have 3. When I have 3, I want to take away the 1. I take away the 1. My final answer is 2. Easy, right? Simple to use, easy to understand. So what I'm doing is I'm just showing you how to move the beads. When I move the beads, then it's easy to understand. And then when I have 4 and I want to take away 2, I'm moving 2 beads. That's all I'm doing. So what we're doing is we're just understanding how to move the beads. It's the same thing with the 4, right? If I have 9, I want to take away 4, I'm going to move all the beads, take away 4. And my final answer is 5. Now, we did 1 to 4. After that is 5. Again, what we're doing is we're noticing our add-in. We only want to focus on our add-in. This add-in is what determines what we're going to be doing. So the first thing we're going to understand is if I have 3, I'm going to have 3. I have 3 on the abacus. I'm going to add the 5. When I add the 5, I have 8. Just as Angel, was it Angel or Becky had mentioned, this is now 8. But again, what we're doing is we're not focusing on the result. We're focusing on the process. Marry the process, divorce the result, right? What do they say? It's all about the journey. It's not about the destination. So what we're doing here is we're understanding that if I want to add the 5, right, I'm going to add the 5. That's what we're doing. We're just adding the 5, and then we can add the 2, right? And then we do it again. We do it again. We do it again with the number 6. We can do it again with the number 6. So if I have 1 here on my abacus, I'm going to add the 1. And then notice when I want to add the 6, I'm going to add the 6. 5 and 6, I'm going to bring it together like that. So my final answer is 7. Anybody have any questions? I know I talk a little fast. Let me know. I can repeat again and go a little bit slower. Here is 2. When I add 2, and then I'm going to add 6. When I add 6, again, when I add the 6, it's going to be 1 bead on top and 1 bead on the bottom. That's what we're going to do is we're going to add the 6, right? We're not going to add the 6 up here. That's 6 as well, but I already had the 2. So to add the 6, I'm going to have 1 bead on top and 1 bead on bottom. It doesn't matter which bead on the bottom I'm using as long as it's 1 bead. Make sense? So when I take away the 6, notice I take it away from the horizontal bar. When I add to the horizontal bar, I'm adding to the horizontal bar. I'm adding to the beads. So this is now 8. When I take away 7, I want to remove it away from the horizontal bar. When I want to add 2, when I want to add 7, or I want to add 8, right? I'm moving all the beads close to the horizontal bar. That's what we're doing. So next thing we're going to do is, that's about it. After that, we're done, right? Are we done? We're done. No, but wait, there's more. So we have 9 and take away 7 looks like that. All right. So the question is what? The question is what happens when we don't have enough beads? Now we get into something cool. Why? Because we are teaching, hello Foxtrot, Tango, Delta, Tango. What we're going to do is we're going to understand, we teach children this. I don't know if you guys remember this. Do you guys remember adding the 5, making a 5? Do you guys remember making a 5 in school? Do you guys remember how to make a 5 in school? So when we made a 5 in school, this is all we're doing, right? Right. Yeah. See, like when I was a kid, I actually never learned how to make a 5. We were taught to memorize. So why are we doing this? This balls. Oh, okay. Yeah. Okay. So they're doing this now. I don't know how early this is, but they're doing this now. They're teaching the kids how to make a 5. So because they're teaching the kids how to make a 5, that's all they do is they teach them how to make a 5. But in the abacus world, we can actually take it one step further. What does that mean? Well, you'll notice that, again, what we're going to do is, let's do this question. We're going to add 3. When we add 3, I want to add the 4. I'm going to add the 4. Notice, when I add the 4, I have this concept. I don't have enough beads to add the 4. That is the problem. The problem is what? I don't have enough beads to add the 4. So what do? Well, I know this idea to 4 plus 1 is equal to 5. Why are we learning this? Why are we learning this? Because we're going to be able to utilize our 5. We're going to utilize our 5 and make sure that our numbers are no longer freeloaders. So what does that mean? Notice that I have the 3. I want to add the 4. When I add the 4, I need to modify Use the money and make it easier. I will use the money. I will. So let me first focus in on the number 4. So when we add the 4, notice that we're going to do is we're going to make it to equal to 5. Because we make it to equal to 5, this is not balanced. What we want to do is want to balance it. Now we're going to take this and we're going to substitute it into this 4. We're going to substitute the 4 to the 5. Why? Because we want to add the 4. When we add the 4, we're going to what? It says add the 5 minus the 1. Now I have directions. I go plus the 5 and minus the 1. So my final answer is 7. Thank you, Angel, for that. Yeah, I was thinking about all the things that I talk about. So, I'm 35 and I'm confused. So what we're going to do is I'm going to show you how to read the abacus. So the first thing to do is to understand how to read the abacus. We're going to count 1, 2, 3, 4. This is 4. After 4 is 5. Now, when we look, none of these columns has any of the beads touching the horizontal bar. The only thing that's touching is this 5. So this is the 5. And then we have 6. And then we have 7. Oh, you guys are so young. We have 7. 8. This is 8. 5 plus 3 is 8. And then this is 9. So what we're doing is we're counting on the abacus. Abacus mimics the way we write. So when we have 9, this is 9, 9, 9, 9. When we do 10, that looks like 10. Because Forever Young. That was a great song. I love that song. So we have 10. After 10, we have 11, 12, 13. Does that make sense, AA? 61, and I just learned this yesterday. Okay, so we have 42. 42 looks like that on the abacus. 61 looks like this on the abacus. That's what 61 looks like. The other one was what? The other one was what? 31? Was it 31? 35. 35 on the abacus looks like 35. 1, 2, 3, 30, and then 5. This is the 5 on the top. So this is what 35 is. Make sense? So when we look, we have 1, 2, 3, 4. Dorothy. Hello, Dorothy. This is 4. Does that make sense what 4 looks like? Anytime the beads are touching the horizontal bar, it's being counted. So this specifically is 4. Right? Yes, thank you. All the blue beads is a value of 5. So this is 5, yes. So when I look, if I have this is 4. When I add the 5, right, there's no, so when I have 1 and I add the 5, now I have 6. If I have 2, I add the 5, now I have 7. If I have 3 and I add the 5, now I have 8. When I have 4, right, 1, 2, 3, 4, and I add the 5, now I have 9. Thank you, AA. Dorothy, does that make sense? I'm getting it. Good. Good. I don't know if Dorothy is here because everybody comes and goes. And I'm not everybody's cup of tea, which is fine too. Oh, good. Thank you. Yes, your father's keeper. Yes. 5, 50, 50, 500, 500, 5,000, 5000, right? 5, 000, and then 55,000. We'll do 55,000. What about the tenths and the hundredth place that are counted with that? Thank you, Gigi. It's over here. It's after the decimal place. So if I did 55,000, I can do 1 cent. 0, 1, 0. 0, 1. I could do that. That's what this would look like, if that makes sense. Right? We can make it into a 9. We do that. 55,000.91. Are all abacus read the same? Yes, exactly. It works exactly how you read it is exactly what it looks like on the abacus. Exactly. Exactly. And so that's why when people are like, is it a binary? It's not binary. It's a decimal system. What we do in regular writing is decimal system. That's what we're doing on the abacus. It's just really just counting. What we're doing is literally just counting on the abacus. But yes, thank you, your father's keeper. I do appreciate that question. Thank you, Gigi. I have one of those collecting dust. Oh, bring it out. Bring it out and we'll start playing with it. Not all abacus are the same, but with the Japanese. You're right. You're right. You're right. We do have a Chinese abacus. This is a Chinese abacus. It works relatively the same. So, unmeric, unmeric. I'm not sure. I hate thinking the numbers, but I like. Oh, good, Lilith. I got it. Okay, everyone. I've been on an abacus. It's 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 the orientation is it make. I'm sorry. I'm sorry. Everyone, I've seen an abacus. Yes, it's turn. Oh, so the one that you've seen it looks like this. Yeah. And is there a difference? Yes. I don't know how to use that one. That's the difference. I don't know how they do place values because we don't write we don't write horizontal. Right? We don't write this way. So I don't know how they figured this out. But yeah, I don't know how to do it. But I think for that one it's a 1-to-1 situation. I literally thought yesterday I wish I could learn this. Oh, hey. Um Let me know what kind of abacus you have. Do you have a 10 bead one or a 5 bead one or a soroban, which is the Japanese one? The Japanese one has 4 beads on the bottom and 1 bead on top. The Chinese one has 5 beads on the bottom and 2 beads on top. Good. Hey, welcome, Beal. How are you today? I'm Merrick. What kind of abacus do you have? And so what we're doing is when we read it, it's still the same thing. 1, 2, 3, 4, 5, right? Same thing here. 1, 2, 3, 4. The 5 will always be the top bead. This will be traded into the top bead like that. So when we look, this is 5. When we do 6, 7, 8, 9, and then 10. Again, we're going to trade this in. I just applied to college. Oh, that's exciting. So when we do this, we trade it in to have the one on top. Yes. Oh, it has 1 bead on top. So then the one you have is a soroban. And so this is what would be. We can do that. Yes, good. Good. Congratulations with the college. Good luck. I know it was a lot of thinking for me. All right. So what we're going to do is understand. So how are we doing? Do we understand how to read the abacus? When we understand how to read the abacus, we understand what's going on. Never mind 2 with the. Oh, yeah. So then that means you have the Chinese one. If you have the Chinese one, if you wanted to follow along, you can just use the ones in the middle. You can do that if you wanted to, right? And you can ignore the ones on the top and the bottom. Yep, you could do that. Oh, thank you, Beal, for the heart me. So it is up to you how you want to use it, but it works relatively the same. The formulas are still very similar. And so you can actually do, because you have yours, you can actually do multiplication, which is kind of cool. So I'm going to do 6, right? I'm going to do 6. And when I do 6, 6 times 1 is 6. 6 times 2 is 12. 10, 11, 12. 6 times, so I'm going to trade this in. This is the 10, so this is now 10. And now I do 6 times 3 is 18. 1, 8, 5, 6, 7, 8. And then 6 times what? 6 times 8, 24, right? 24, because it's a 2. So we trade this in, that'll be 20, and this is 4. I don't want to go, but I have to. Oh, thank you, Chase. Like food? No, I'm always live. CompuBear even mentioned. I'm always live. So if you want to catch me later, catch me later. Just follow me and you'll see when I'm on live. Yeah. Thank you for all of the comments. Thank you for being patient when I was a little bit salty in the morning or beginning of the live. Oh, I need to stop reading my things. I always miss the part explaining the multiplication on the abacus. Yeah. It all depends on how far the class is. And I do appreciate everybody being here and commenting and being patient with me when I get a little bit salty. I have to stop reading those comments. That's what I got to do. Okay. So what are we going to do? So what we're going to do is we're going to understand how to make a 5. We're going to make a 5. We know how to make a 5. We're making a 5. We're going to make a 5. We're going to understand this concept. The reason why we're going to understand this concept is because on the abacus, we don't have enough beats to add the 4. We're not going to memorize. I stayed up till 2 in the morning to get on vacation. Notice we're going to add the 4. We add the 4. There's not enough beats to add the 4. So what are we going to do? We're going to add the 4. We don't have enough beats to add the 4. What do? We are going to plus the 4 is equal to plus the 5 minus the 1. So what are we going to do? We're going to plus the 5 and we're going to take away the 1. Our final answer is 7. We can go into multiplication, but I don't know if anybody else wants to go to multiplication. Wow, I should do this, Japan. Yeah. Okay, Japan. Yeah, I think it's great. I think it's the greatest thing next to sliced bread. And if you ever want to, oh wait, Boss has been around for a while. All right, how are we doing? Thank you, everybody, for the hearts. I have 2,800 hearts. Thank you. And there's 44 people in the room. Wow. Should we go into multiplication? How are we doing? I am slow. Learn to have a series. I do have a series, actually. This one here is my plus the 5. And so this one goes through. And, thank you so much, Lilith. So when we do it, almost daily, if not daily, yeah. So what's going to happen is we don't know what this is, right? We're going to add the 4. We add 3. We have the 3 on the abacus. My question is I want to add the 4. Do we have enough beads to add the 4? No, I don't have enough beads to add the 4. So what I did here is I added a little story. I have 5 cats in a tree. I will always have 5 cats in a tree. When I have 5 cats in a tree, I will take 4 cats and 1 cat runs away. So that means when I go to the cats in the tree, I'm going to add the 5. But 1 cat runs away. So then my final answer is 7. I did Sorbonne for 5 years. I did competitive, won second place. I should teach too. What do you? I think you should. I think you should. I do think you should because I think the Soroban is the greatest thing next to sliced bread. And there's not too many people that are teaching. And if you can relate it, then it'd be fantastic. I think you should, Japan. So, Lilith, did that make sense? To how to make a 5? We can do another one. We can do another one. So if I have 3, I have 3 pennies, right? If I have 3 pennies, I'm not sure where you are, but pennies is worth 1, right? Facts. It makes math very easy. Yes, you're right, Japan. So Lilith, I don't know if you're still here. So what I'm going to do is I'm going to have 3. I have 3, and something costs 4 cents, but I only have I only have 5 cents. I'm not sure where you are, but I only have a nickel. I only have 5 cents. I'm going to give you this nickel, but that's too much. I need to take one back. So what we're doing is we're doing an exchange. So my final answer is 7. That's what we're doing with this bead over here. Does that make sense? Can you do 6 plus 6? Yes, we can do 6 plus 6. Okay, so I don't know if Lilith is still around. I am going to continue on. So 6 plus 6, that is a two-step equation. Why is it a two-step equation? Because we have to understand our plus 10s. So the first thing we're going to understand is when we add the 6. So when we add the 6, right, the first thing we're going to do is we're going to understand what 6 plus 6 is. So let's do 8 plus, no, 9. 9 plus 6. We're going to do 9 plus 6. So on the abacus, we're going to do 9. We do 9, and then we're going to add the 6. When we add the 6, we can't do it. Can we do it? No, we can't do it. So what are you going to do? We know how to add a 6. To add the 6, we're going to utilize the 4, right? The family of 4. The partner of 6 is 4. So what does that mean? When we do our partners, right, we have this. We have our formula to understand how to make a 10. When we make a 10, what are we going to do? We're going to isolate this variable. We're going to move the 4 to the other side. So when we move the 4 to the other side, we're going to do 6 is equal to plus the 10 minus 4. Why? Because if we do plus the 10, that's not balanced. So what we're going to do is we're going to minus the 4. When we minus the 4, that's what we're going to do. We're going to plus the 10. 10 is a 0 and a 1. We're going to add the 10. 0 and 1. 1 and 0. And then what do? We have to take away the 4. When we take away the 4, is there enough beads to take away the 4? Yes, there is. So I'm going to take away the 4. So my final answer is 15. So the original question, we understand that. Minus the 10, plus the 10 minus the 4. So the original question was 6 plus 6. And again, we don't memorize doubles. What we do memorize is our formula. It is plus the 10 minus the 4. When I look at this, I know that I'm going to have a 6. Now I'm going to plus the 6. I don't have enough beads to plus the 6. What do? I don't have enough to add the 6. I need to plus the 10 minus the 4. I'm going to plus the 10, take away the 4. Whoa. I cannot take away the 4. This is literally what? I'm sorry. This literate in math. I don't know what that means. So we're going to minus the 4. When we minus the 4, can we do it? No, we can't. We cannot minus the 4. Now here's a little bit of magic. What we're going to do is understand that when I minus the 4, remember, we have to make a 5. When we make a 5, what does that mean? It goes back to our formula. I'm confused. Okay. Did you understand this, CompuBear? To be fair, when you are shown the abacus, it's only hard to understand unless you know the place, values of the beads. Like this. Just keep going. All right. Okay, I just want to make sure CompuBear understands this. Okay, so we're going back to here. 6. When we add the 6, right, we want to add this 6. Hey, Cam, welcome back. Right? We want to add this 6. Because we want to add this 6, we don't have enough beads. What do? We have to plus the 10 minus the 4. We're going to plus the 10. 1, 0. That's a 10. 1, 0. Right? 1, 0. I'm going to add the 10 over here. 1, 0. 0, 1. Now I need to add the 4. Can I add the 4? That's the question. Can I add the 4 here? Can I add the 4? No. Thank you, citizen. You're right. I cannot add the 4. Do you remember? Do you remember what we do? We want to minus the 4. Yes, we want to minus the 4. How do we minus the 4? Almost, Jay. We got it backwards. Almost. Why? Because we have to minus the 5. We want to take away the 4. We want to minus the 5. Yes. So we want to, when we minus the 4, it's equal to minus the 5 plus the 1. Because we're taking this 1 and we move it over here. We want to minus the 4. When we minus the 4, we're going to minus the 5. And we're going to add the 1. So my final answer is 12. Yes, thank you, Jay. Yes, right? So what did we just do? We understood our concept of how to make a 5. Yes. Nope, you're good. You're good. And then minus the 1, minus the 5, minus the 5. Citizen, yes, minus the 5. The reason why is because we're going to take away the 4. When we take away the 4, when we need to take away anything, right? If we need to take away anything, like minus 4, minus 3, minus 2, minus 1, it will always be minus 5. If I need to plus the 5, I will be plus the 4, plus the 3, plus the 2, plus the 1. It will always be a plus 5. Yeah, that's how I remember it. So what we're trying to do is we're trying to take away the 4. When I take away the 4, I want to minus the 5. And I know what the partner is. I know the partner is 1. Yeah? How are we doing? So my final answer is 12. Final answer is 12. Does that make sense? So what are we doing here? What we did was a two-step equation. That is what this is. This right here makes it a two-step equation because when I initially had it, I cannot take away the 4. That is why it is now a two-step equation. Here, when we had 9, and we want to add the 6, did we have enough? Yes, we did, right? Yes, we did. So we add the 10 minus the 4. So that's why when we do a 6 again, we do it again. It's the same formula. It's the same formula, but now it's a little bit different. And it goes back to understanding the process and not the result. So we can do it again. Let's do it again. I don't know if we remember this one, but I had a parent and she was like, isn't 5 and 8 the same as 8 and 5? No. Why? Because it's always about the add-in. It's always about this thing right here. It all depends on the journey. When we show the 8 and we want to add the 5, we know how to add the 5. Adding the 5 is plus the 5 is equal to plus the 10 minus the 5. Plus the 10 minus the 5. So my final answer is 13. Great! Let's do the next one. We had 5 and we add the 8. When we add the 8, is there enough beads to add the 8? No, there isn't. There is not enough beads to add the 8. Right? There's not enough beads. Thank you, balls. There's not enough beads to add the 8. What do? I know to add the 8, the partner is 2. So plus 8 is equal to plus 10. But that's too much. We got to, yes, thank you, balls. We got to take away the 2. Oh, you can't see that. We got to take away the 2. So we plus the 10 and we take away the 2. Ooh, wait a minute. Hold your horses. I want to take away the 2. Now what? Hey, Em, welcome back. Now what? We want to take away the 2. Cannot take away the 2. What do we do? Minus the 2. So we go back, right? We go back to our formula. Nope, not that one. Thank you, balls. Yes, minus the 2. Minus the 2 is what? Minus 2 is equal to minus 5 plus the 3. There we go. So my final answer is 13. Thank you, Beals. Yes, compute bear and balls. Right? Make sense? Hooray! Melinda, you're so cute. So that's how we do it. That's how we do it. Ugh, I love that. I love that movie. So, yeah, that makes sense. So what we just did is we're understanding how to use the formulas. We understand to make a 5 and to make a 10. That's everything under the sun. Now it's scalable. Thank you so much for the likes. Now, any question you have, it is now scalable. We can do another question. Let me show you how easy this question is. Let's do this question. The soundboard, right? You like it? Oh, did you hear this one? I like this one. Becoming a DJ? God, I wish. I don't have the skills to. I do not have the skills to, but I would love to be a DJ. I listen to DJs all the time. That and comedians. I love comedians. Okay, so here's the question. This is a 3-digit, right? 283. Now, if you notice, we can actually focus and understand what we're doing here. Hi, dog. When we do, we have the question, is there enough beats to add the 5? Is there enough beats to add the 5? All we got to do is just add the 5. Then the question is to add the 1. Can we add the 1? Right? And then we do it again. Can we add the 6? So notice there is no formulas here. So that's the easy thing. When we look at our abacus, we can see what we can do and we don't have to do. Thank you for the flower headband and the heart puff. Thank you, guys. Thank you. Does that make sense? Nikki, hey, Nikki, welcome back. Does that make sense? So this is a 3-digit column, 3-digit question. And the answer was 799. Yeah. So then there was another one. There was this one. This was a minus. This is easy too, right? We have 34. And then this was take away 24. Is there enough to take away 24? Yes. So we take away 20 and we take away 4. My final answer is 10. Yes, thank you, Melinda. Yes, 799, right? So then there was another one I was doing. Oh, I did another one. Another one was kind of cool because it was a 5-digit. I need to find it. Oh, here it is. Here it is. Here it is. This was the cool one. Here is the one. So this is a 5-digit one, right? That's really big numbers. It's easy. I'm telling you. We do 1, 2, 3, 4, 5. We know 1, 2, 3, 4, 5. We do 1, 3, 5, 7, 8. Then what do? We add 2. Can we do it? Yes. Can we add 4? We cannot add the 4 because there's 3 beads here. There's 3 here. What do we do to add the 4? How do we add the 4? Now we're position agnostic. How do you add the 4 here? Do we remember how to add the 4? Do you remember how to add the 4? plus 4 is equal to plus 5 minus 1. Yes. So I add the 5, take away the 1. Yes, thank you, Melinda CompuBear. Thank you. So then the next one is add the 3. I have a 5. I want to add the 3. I have 7. I have 1 and add 1. So my final answer is, oh my gosh, my final answer is 37,888. So what did we just do? We just did a plus 5 formula within a 5-digit abacus, 5 digits. So this is where now it becomes scalable. We don't need to say, oh, let's make this a 10 and move it down. Yes, 37,889. Yes. Does that make sense? So what I just showed you here is now it's scalable. You don't need to do the other strategies like, I don't know, matrix or whatever. Thank you, Claude. Hey, welcome back. There is no carrying. Not this one. We can do a carrying over, but not this one. Right? And so when we look, I like this one just because I can show you how versatile it is. You know who this is? Just joined my post. Oh, thank you. All right. So what are we going to do? We're going to continue on with some adding and subtracting. How are we doing? I'm on my last page. You should develop an app or a website where everyone gets a digital abacus and you could see us use it. Yes, that would take time. But can you do carrying? Yes, we can. Let's do it. So the first thing we're going to do is understand how to make a 10. To carry, right? To carry, we need to understand how to make a 10. So the biggest thing is what? We can do, 19 plus 9. That's the easy one. So, and make sure people aren't just doing math, but following along with the abacus. So here we are. We have the 9. What are we going to do? Well, I gotta find my 9. How do we add the 9? We add the 9 by this formula. We know how to add the 9. Plus 9 is equal to 9 plus 1 is equal to 10. Yeah, David, we're all right? So what I'm going to do is I want to add the 9. I have on my abacus 1 and 9. I don't have enough beads to add another 9. If I don't have enough beads to add another 9, what do? I need to go back to my formula and I need to isolate my 9. When I isolate my 9, right, I have this, and I'm going to move this to the other side. So if I did 9 is equal to 10, that is no longer balanced. I need to minus the 1. So when I want to add the 9, I want to add this 9, I'm going to substitute plus the 10 minus the 1. My final answer is, what's my final answer? Thank you, Jay. Gotcha. That's not an answer, David. 28. Thank you. 28. So what did we just do? We just did a carrying. We just did a carrying on. Carrying on. I think that's what it is. Carrying on. Thank you, Balls. Thank you, Melinda. Thank you, Claudia. Thank you, Tammy. Right? Does that make sense? Right? So what we can do it again. We can do it again. Let's do 37 plus 8. Right? So we're going to do 37, we do 30, we do 7. And then what are we going to do? We're going to plus the 8. When we plus the 8, what are we going to do? Do we have enough beads to plus the 8? No, we don't. We don't. I don't know what soundbite I would use to say no. Anyways, so we're adding the 8. When we add the 8, we need to do what? 8 is equal to 10. Notice 10 is too much. We need to minus the 2. So if we want to add the 8, I want to add the 8. What do? Plus the 10. Thank you, CompuBear. Thank you, Balls. Plus the 10 minus the 2. Minus the 2. So my final answer is 45. No. Oh, maybe I should take a Russell Peters' sound bit. Maybe I'll do that. No, it's the longest no that you've ever heard. Oh, that would have been a good one. I don't know if anybody knows Russell Peters. I love him. He's so funny. I liked his earlier stuff. 45. Yes, thank you. 45. He has funny stuff at the beginning. And he talks about like his dad, his Indian dad, and his Yeah, anyways, I like him. He's funny. The later ones is not so funny, but his earlier ones was. Hey, Annabelle, welcome back. So, how are we doing? So that's what carrying over. We can do it. We can do what? We can do it the opposite, right? Notice, what are we going to do? We're going to do, okay, we'll do, here, we'll do this one. 34 minus 5. That should be easy. But I read the abacus is 34. 37, 45. It might have been that I did this, and it might have messed up my answers. It could be that. Because the abacus is very easy to mess up the answers. Yeah. Yeah. The abacus was bumped. Yeah. The abacus was bumped. And that's the thing, right? So here we go. 34. Right? I'm going to take away 5. To take away the 5, what can I do? I cannot take away the 5. What do? I know how to take away the 5. I'm going to bed. Oh, go to bed. Have a great day. Thank you so much for dropping by, Beal. So we're going to do a 5. When we 5 minus the 5, we're going to minus the 10, but we're going to plus the 5. Plus the 5. Thank you. Oh, sorry. Plus the 5. So what are we going to do? I have 34. What do? I have to minus the 10 plus the 5. I'm going to minus the 10. I'm going to plus the 5. So my final answer is, thank you, Balls. Thank you, CompuBear. Yes, thank you. Thank you, David. Right? What is my final answer? My final answer is 29. So notice, if we could add it, we can subtract it, right? It's not another strategy. Thank you, Tammy. Right? It's not another strategy. It's just the opposite operators. Thank you, Claudia. Does that make sense? So what we're doing is we're solidifying our concept of, we know how to add, now we know how to subtract, where it's not a new set of strategies to subtract. Yes. Okay, good. Yes. Right? Easy. Simple to use, easy to understand. But the biggest thing is to understand the fundamentals. And these are the fundamentals. Understanding how to add and subtract, the 5 and the 10 is a fundamental. It's a fundamental thing. You're such an awesome teacher. Oh, thank you, CompuBear. Thank you. I appreciate that. I enjoy teaching and people making aha moments. Or the other one. Oh no, that's not it. Some people think I'm a magician teacher, but it's not. It's just about moving the beads, which is really great. Now I understand the strategies now more than last night. Yeah. Well, last night was also really late. We were up really late. You guys were crazy, like learning in the middle of the night. Okay. How are we doing? I'm going to have another 10 more minutes and then I'm going to go have some. Yeah, that's what I'm saying. That's what I'm saying. You guys were nuts. And yet you guys were still trucking along, doing math in the middle of the night. Better than doom scrolling. I appreciate that. I hope that I am entertaining enough. And I am. Oh yeah, I finally got this one up on my TikTok shop. So if anybody's interested, I have that. I gave up at 1:30. Yeah, I would give up too. But when I start making mistakes is when I'm like, okay, you know what, I'm done. But anyways, so how are we doing? Do we want to do that? We can do multiplication. Multiplication. So multiplication. Are we ready for multiplication? How are we doing? I'm glad you finally got the TikTok shop up on the live. Yeah, that took a bit, right? Whew! I'm telling you. Now it's just trying to populate it all. So I got some more abacus. I got some more, and then I'm bringing in some more books. I'm just waiting for the books to come in. All right, and then I'll have more. All right. Multiplication. Okay, this will be easy. This is so easy. You guys, multiplication is so easy. If everyone is caught up. I believe everybody's caught up. Ooh, that's not the right one. I believe everybody's caught up. How are we doing? Let me know if you are confused. Let me know. We can do a review. Let's do a review. But thank you, Compy Bear. That's exactly very, very nice of you. And thank you for reminding me because I keep forgetting. Like I just keep going, you know? Okay. Let's do a review. We'll do a review. Let's do a quick one and then we'll do into some multiplication. So we're going to count on the abacus. We're going to count the abacus. We're going to 1, 2, 3, 4. All the beads touching this horizontal bar is considered counted. So when the beads are touching the horizontal bar, it's being counted. And then we have 4. After 4 is 5. The top bead will always be a value of 5, no matter what. No matter what, the top bead will be a value of 5. Oh, show the placement with the new joins. Okay, so there we go. Thank you, balls. So we have 1, 2, 3, 4. You know, I do wonder if this gets confusing because it's all the labels. So that was me last night. And that's what I wondered. That's why I only do it after I finish counting. But 5, this is 5. This is the value of 5. Because this is 5, we have 6, 7, 8, 9, and then we have 10. If you notice, we have our 0 and our 1. That's a 10. We can count by tens now. 10, 20, 30, 40. And then, oh, look, 50. This is 50. Now, if you look, this is 5. This is 50. This is 500, 5,000, 50,000. When we look, we have these are all place values. Every one of these columns is a place value. If I do this, this is 9. So we have 5, 6, 7, 8, 9. How do I get that? Well, if I do 1 and then plus the 5, now we have 6. If I have 2 and I plus the 5, now I have 7. When I have 3 and I plus the 5, now I have 8. And I have 4 plus the 5, now I have 9. And then when I do 10, it looks very familiar. Because why? This is 1. This is 10. 100. 1,000. 10,000. Right? How are we doing? We're all right? Okay. Multiplication. Are we ready? There's a few things we need to understand with multiplication. Multiplication. Yes, we are food. All right. 7, 6 times that by 2. Now what's going to happen is we're going to understand where are we going to put our digits. To put our digits, what we need to do is we need to count the digits. Notice I'm going to add all my digits together so I know where I'm going to go. How many digits do I have? 1, 2, 3. That's it. 1, 2, 3. My answer is going to be somewhere around here. It's going to be either more or less, but it's going to be right around here. It's a ballpark. It's a guesstimation. 1, 2, 3. I'm going to be over here somewhere. 2 times 4. Sorry. 2 times 7 is 14. I add 1. I add 4. Right? What's next? 2 times 6. 2 times 6 is 12. I add 1. Whoa. We know how to add the 1. Do we have enough beats to add the 1 here? No. No, we don't. How do you add the 1? How do you add the 1 to this? Thank you, Compy Bear. Yes. Minus the 2. Balls. No, can't be minus the 10 because we're going to minus the 5. Or we're going to add the 5, right? Going 10 is too far. So what we're doing is we're going to, I'm trying to find my, oh please. Let me see. I'm trying to find my. Is it this one? No, it's not this one. Where is it? Let me find my checklist. It will help you with this. It will help. It will help. Let me find my checklist. I know what the situation is. I just need to find the. Is it here? It is here. Oh, yes, it's here. Here it is. So this is what we would do, right? So what we would do is balls. What we do is we check to see if we have enough beads. What are we doing? We're adding the one. So what we're going to do is we're adding. So is there enough beads? Yes or no? No. So then we go down here. The next thing we need to do is, can we add the 5? Yes, we can use the 5. That's when we do this one. Plus the 5 minus the 4. So this is the checklist that way I would go through my head. So I'm going to plus the 5 minus the 4. And then I'm going to plus the 2. So I add the 2, if that helps. So this is the abacus framework that I would go through in my head every time we have a number. So when we look, I want to plus the 5. My question was here. Plus the 1, not enough. Plus the 5 minus the 2, and then add the 2. Yeah? Does that make sense? Cool. Yes. So our answer is, that one lost me for some reason. Is it the checklist? I just showed my daughter how to count on the other. Oh, yay! Kendra. Oh, good. That one lost me for some reason. Yeah, sometimes if we go too far, then it's too much. We don't want to go all the way here. We want to, the first step is always, you know what? It's because it's the first number. Every time, anytime it's the adding of the 1 or adding of the 5 or minus, no, not the 5. If you notice, 1 and 1 has 2. The answer is yes, 152. Yes, Claudia. So if you notice, balls, there's going to be 2 formulas for one number. Plus 1 can either be plus the 5 minus the 4, or it can be plus the 10 minus the 9. 2 has the same problem. Either can be plus the 5 minus 3, or plus the 10 minus the 2, and minus 3. Plus the 3. Plus 3 is plus the 5 minus 2, or plus the 10 minus 7. So this is why we have to go through the framework to figure out which one we have to use. And we always start with the smallest one first, and then we go to the big one. Welcome back, lovely. Does that make sense, balls? So when we look, we're not going to have the problem with the 6. However, this is where we get the 2-step. Notice it says plus the 10 minus the 4. Well, when we minus the 4, right, that looks very familiar. Minus the 4 can be minus the 5 plus the 1. This is where we get 2-step equations, right? And it's the same thing with the others. The 7 and then minus the 3. Minus the 3, right, it can be minus the 5 plus the 2. So, but this is all about understanding how to Tetris our blocks, if that makes sense. So what we are doing is we were adding a 5 here. Yeah? All right. How are we doing? On that note, thank you everybody for joining. Hello. Tell me about you. Hey. Welcome. Welcome, lovely. I was actually just about to sign off because I'm going to go have some dinner. Thank you for joining. Thank you for joining. Audrey is awesome. Anybody wants algebra, please go to Audrey. I guess I don't want to hold everyone up. I'm sure I'll get in next class. balls. I guess, yeah. I don't want to hold everyone up. I'm sure I'll get it next class. You know what? Next time, we can do another one. Let's see. Let's do another one. We can do 39. Let's do 39 times up by 4. 39 times up by 4, right? If we do 39 times 4, again, what are we going to do? We're going to count our digits. 1, 2, 3. We're going to do 1, 2, 3. We know 4 times 3 is equal to 12. I add my 1. I add my 2. And then what are we going to do? 4 times 9. 4 times 9 is what? 36. I want to add 3. I want to add 6. I want to add 3. How do I add the 3? Is there enough beads to add the 3? There is not enough beads to add the 3. If there's not enough beads to add the 3, what is the first thing we need to do? Plus the 5 minus the 2. Thank you, CompuBear. Thank you, Melinda. Thank you, Balls. Yes, plus the 5. So we're going to add the 5 minus the 2. And then we add the 6. And then we add the 6. And that's it. Yeah? Make sense? So what it is really is just taking it one number at a time. Don't be jumping ahead. It is one number at a time. Yes, thank you, Melinda. 156. What? Nope, 156. That's right. Oh, I see. Oh, I think the adding the last number is what confuses me. Yeah, because we're doing too much, right? You got to do one number at a time, right? Because we added the 3 and then we needed to add the 6. That's all it was. We just needed to add the 6. Yep. See? Easy. You got it. All right. Thank you everybody for joining. Thank you everybody for commenting, and thank you everybody for. I'm not sure how this goes. Let's do a little review before we head out. We're doing math now. You're doing math now. The 99 add 3 helps. Oh, yeah, right? Okay, wait. Lovely. What we're going to do is we're going to review. When we review, we're going to count on the abacus. 1, 2, 3, 4. This is a value of 4. Anytime the beads are touching the horizontal bar, this is being counted. Because this is 4, right? What is 5? 5 will always be the top bead. Got it. Thank you for the review. Someday we'll get to division. Someday. I know Melinda keeps waiting for division. So we have 5. If I do 1, I'm going to add 5. Now we have 6. We have 2. We've seen 2 before. We add 5. Now we have 7. We have 3. 1, 2, 3. We add the 5. Now we have 8. 5 plus 3 is 8. And then 4. Here's 4. This is amazing. Mahalo Mocho for teaching us. Oh yeah, not a problem. I'm always ready to do it with my own abacus. Oh, that's fantastic. Anyways. So we have the 4. 1, 2, 3, 4. When we add the 5, now we have 9. Does that make sense, lovely? Marco, that's pretty cool. Thank you, Marco. Lovely, did that make sense? So when we do, what happens after that? We have 10. If we notice, every column is a place value. So we can do 10. 10 looks like this. This is 10. 1 and 0. 10. 11, 12, 13, 14. After 14 is 15. It's exactly the same. We can count by 10s now. 10, 20, 30, 40. 50, 60, 70, 80, 90, and then we have 100. We can show what 2025 looks like. 2025, 2025. So Claudia has a number. Claudia is 704. Claudia's number is 704. Right? Oh, Dimples is 46. So Lovely is 46. We have 40, and then we add 6. Yeah? Great! That's about how to read the abacus. And then we go into adding, subtracting, multiplication, division. Um, you kind of came in multiplication. So left gets larger or the video's opposite? No, no, left is larger. So this is the tens, 10,000, 1,000, 100, 10,000, tens and ones. Yep, yep. No, that's a good question. But no, I try to make sure that it reads well. Because if you look, my 2 is here, right? 760, 67, right? 67. Or the other one number, was it? 29, right? It's not backwards. So just as we have 29 is 20 and the 9, tens and the ones. Yeah, right? Makes sense? Thank you. So it should not be backwards. If it backwards, then it'd be just confusing. I don't need abacus to be more confusing because people already complain how difficult it is. But it's not, right? It all makes sense. So the idea was that we have our thousands, thousands and hundreds. And then sometimes if you notice, we have a dot here. This dot is our ones indicator. So we have our ones or we have our ones. But notice we can group them. If I choose this to be my ones, like a Pokemon, I can move everything over. But then the problem is I don't have any hundreds. It'll be my ones, my tens, and my no hundreds, right? Should I buy a 7 or a 13? If it's for you, I would recommend the 13. The reason why is so then you can do multiplication. Multiplication! So what CompuBear was talking about was, hey, JL, yes. So the blue ones is 5, 50, 500, 5,000, 50,000. Yes. CompuBear, I would recommend the if it's for you, I do the 13 column one so then you can do multiplication and division without any problems. Because the 7 column one is a little bit more difficult and it also depends on how big your question gets. Your question will get kind of big because sometimes we'll do 4 times 4 digits times 4 digits. Oh, Abacus makes it easy. So I think the biggest number I would probably go for would be like 4 digits times 4 digits. So it'd be 3, 4, 6, 7 times that by 8, 2, 3, 4, right? So then this would be 1. So then when we count it, it would be 1, 2, 3, 4, 5, 6, 7, 8. So that's why it'd be better to do this. So it does depend on how big you think your numbers are going to be. That's all it would be. So we can talk about multiplication at a later time. But I am going to head out. CompuBear, depends on what you're using it for. Yeah. Yeah, it really does depend on how big the questions are, right? I mean, if it's for young kids, the questions would not get too big, right? Mahalo. Oh, mahalo to you too. Innate evolution. Money. No, it just depends. If you're talking about the national debt, then I would get the 23 column one. Right? No, it depends on how much money you're going to use, right? So if you're only going to use like 10,000, then that's fine. But if you're going to use more than 10,000, because we go to millions, we can do trillions, ones, thousands, millions, billions, and then trillions. Excuse me. But if you're just taking it to the grocery store, then the 7 column one would be fine. Have a good night, balls. Back to doom scrolling. Have a good night. Have a good night. Have a good night, everybody. Thank you, guys. I might be on later tonight, depending on how I feel. But I don't know. Have a good night, everybody. Have a good night. And I'll see you guys all in my next live. Back to doom scrolling. All right. Yay. Good night. Good night. Wow, I got 500. Wow, Beal, you're so generous. 20. Oh, I have to end my stream.